Chapter 4, Section 3, Rational Exponents. So instead of just limiting ourselves to exponents that are whole numbers, positive or negative, we're actually going to begin to look at exponents that are fractions. As if you thought negatives weren't bad enough. Yes, we can have fractional exponents. Okay? Please don't freak out. It's pretty simple. Just bear with me. So 9 squared. Let's start nice and simple. That just means 9 times 9, which is 81. Okay? The previous section we introduced negative exponents. Well, that is the same as 1 over 9 to the positive 2, which when evaluated is 1 over 81. What if I have 9 to the power of 1/2? It turns out the answer is 3. Why? Well, I will explain that right now. Alright, so here's the technique on how to go from 9 to the 1/2 being 3. What we do is we express the base, in this case the base is 9, as a power. Hopefully such that the exponent simplifies with the denominator of the fractional exponent, that being the 1/2. Here's what that all means. So I'm going to take the base, which is 9. Remember, it's still being raised to the 1/2. But I'm going to write 9 as a power. Remember, the 9 is the same as 3 squared. Well, we can apply our exponent laws. If I have a power and then I'm raising it again, well, can't I just multiply those together? That's not new. And what is 2 times 1 over 2? 2 times 1/2. Well, the 2's cancel. That just gives me 1. And 3 to the 1, of course, is 3. So that's showing the steps. Let's evaluate a few more. What is 49 to the power of 1/2? Okay, so 49, that's the same as 7 squared. And that's very nice, because when I multiply these two together, 2 times 1 over 2, the 2's cancel. So I'm left with 7 to the 1, or 7. So 49 to the power of 1/2 is 7. 8 to the power of 2/3. Well, it would be really nice if I could get rid of this fraction somehow. It's the 3 in the denominator that's causing all the trouble. Well, wouldn't you know, 8 is a perfect cube, because 8 is 2 to the power of 3. But now I can multiply these two exponents together. What is 3 times 2 over 3? Well, the 3's just cancel, and I'm just still left with the 2. And 2 squared, that's easy, that's 4. So 8 to the power of 2/3 is 4. Next, 25 to the 3/2. Okay. It's the 2 in the denominator that's causing the trouble. Fortunately, I can write 25 as 5 squared. Now I'll multiply these exponents. 2 times 3 over 2. The 2's just cancel. So that leaves me with 5 cubed. 5 times 5 times 5 is 125. So 25 to the power of 3 over 2 is 125. Alright, let's do some simplifying, but with fractional exponents. Well, the good news is that all of the rules that we've ever worked with involving powers are the same. It doesn't matter whether the exponents are positive, negative, whole numbers, fractions. It doesn't matter. All the rules still apply. So x to the 1/3 times x to the 1/2. Well, I get to add the exponents. So that is x to the 1/3 plus 1/2. Now you're adding fractions. You're required to find a common denominator. Okay. The lowest common denominator between 3 and 2 is 6. So this gives me 2 over 6, and this gives 3 over 6. And now I can add, this gives me x to the power of 5/6. Next, we have a division of some powers. The bases are the same, but we get to subtract the exponents. So that would be x to the negative 1/3 minus negative 2. Well, when you're subtracting a negative 2, remember that's the same as plus 2. So I'm still subtracting, but because this is already a minus, I just didn't bother writing minus minus. I just wrote plus. Okay, well, I need to find a common denominator here. Remember, there's an invisible 1 here. So the lowest common denominator, of course, is 3. So that would be 6 over 3. All right, so now I can add them together. Okay. Negative 1/3 plus 6/3 is 5/3. Okay, and that's as far as I can go. So I actually don't even need that. Finally, x to the 1/2 to the power of 4/3. Well, I can multiply these together. Okay. So what is 1/2 times 4/3? Well, 1 times 4 is 4, and 2 times 3 is 6. Okay. Now, this is reducible. And we're done. So I don't need that one.